Let me give an overview about the contents. First, we will speak about fundamentals in science, systems based on information. Then we will have a look to statements about laws of nature and searching for information in biological systems. Before we will find the laws of nature about information. And the most important thing of this lecture is to find 7 strong conclusions. Part 1, Fundamentals in Science. How to refute false ideas in science. Let me start with an example in mathematics. You see there is an equation and you see the equation is false because a law of mathematics is violated. And you see the other equation which is right. That is very important in science, that we find what is the wrong situation and what is the right situation. Let me give another example in physics. Water is running up and falls down in a waterfall, as you see here in the picture. Is it possible or not? It is false because the law of energy of conservation is violated. So it's an impossible process. Or another example from chemistry, you see an equation of reaction, and there is also, the equation is false because the law of stoichiometry is violated. You see in the equation H3O, and the right equation must be H2O. Now let me come to an example from biology. Man has evolved from a long process of evolution. False, because a law is violated. But the question is, do we have such a law? We will find out laws of nature which can give us the right answer. That's what I want to show you in this session. What is the general term for a law of gravity or conservation of energy law? In Germany we say Naturgesetz, in the United States they say scientific law, and in England we say law of nature, and I will use this term. In nature we observe the non-systems by observation and experiments, and so we find out the laws of nature. And if we know the laws of nature, we can use the laws for unknown systems and we will find conclusions. That's what I want to show you in this afternoon. Here you see different levels of scientific knowledge. Above of the red line you see the laws of nature, and we can say the laws of nature originated from God. And the laws of nature are formulated by men. But we have other laws of scientific knowledge. You see models or speculations, hypotheses or theories. All this below the red line we can say are originated and formulated by men. You see, there is a very large gap between the laws of nature and all the other levels of scientific knowledge. Therefore, it is possible that a law of nature can refute a model or a speculation or a theory. In our world, we have 3 kinds of realities: matter, information, and life. What is the best understanding of such systems? Of course, it is if we know laws of nature about these 3 possibilities. The laws of nature about matter are well known in physics and in chemistry. But the laws of nature about information are very new. We need such laws of nature, we will see it later on. And we also need laws of nature about life. At the moment we only know one law of nature about life. It is from Pasteur coming. He said, life is only coming from life. It is the only law of nature we know about life. Let's have a look to systems which are based on information. On this picture you see a walking machine. It has 6 legs and there is a computer installed and a special program, and so this machine can walk on plane and unplane surfaces. It can go upstairs and downstairs and so on. What is the most important detail on this machine? Of course, it is the program. The program allows it to do it. If we would delete the program, then it cannot walk. Now, let's have an idea about this walking machine. If we would weigh the complete system, we will find a special value of the complete machine. Afterwards, we will delete the information, and then we would weigh it once again. What do you think about the weight of the complete system after deleting the information? Will it have more, less, or the same weight? Of course, it has the same weight. What is the conclusion? Information is not a part of matter. Information is a non-material entity, a very, very important conclusion. On this picture you see a stick insect. It is also a walking machine, a biological walking machine. It had also 6 legs, and we can say it has also a program installed that it can walk in all kinds of bushes and trees and so on. If we would delete this program, it cannot walk. But we don't know the place where to delete the program. On this picture you see an ant with a microchip. The microchip represents matter plus information, and the ant represents matter plus information plus life. Maybe the next generation of computers will be installed by the ants. On this picture you see the development of an embryo that is the most complex information system. Now let me come to a few statements about laws of nature. It is necessary to understand what the law of nature is. We have 2 kinds of laws of nature. For material entities, for example, energy, power and electricity, and non-material entities, for example, information. And that's what we will speak about this afternoon. Laws of nature are precise statements based on discoveries through observation and experiment that have been repeatedly verified and never contradicted. Very important statement. Laws of nature are universally valid. They are valid in Australia, they are valid in Germany, in America, on the moon, and in the complete universe. Laws of nature do not vary in time. It's also a very important statement. If it would not so in this way, we couldn't construct motors on bridges and so on, because all our constructions are based on the laws of nature. Laws of nature are simple. That's a very good thing. Therefore, we can learn a few laws of nature about information on this afternoon. And a very important statement is this one: there are no exceptions from laws of nature. That makes it so important for the laws of nature in our using. Laws of nature enable us to determine beforehand whether a proposed process is or is not possible. That's a very, very important statement about laws of nature. Once again, this picture with water which is running up this way and falls down. We can say it is an impossible process because there is a law of nature which says no. So it's an impossible process. Now we will find a definition of information, a scientific definition. What is information? The American mathematician Norbert Wiener said, information is information, neither matter nor energy. It's a very good statement. He said, information is not matter and information is not energy. But he didn't tell us what it is. And that's what I want to show you now. On this picture, you see different signs, and my question is it information? And the answer is, it could be, but it could also not be. What is the right answer? In 1799, soldiers of Napoleon found in the Nile town of Rosetta this stone. On the same stone, there are texts in 3 languages, in Greek, Demotic, and in hieroglyphics. It was a long time of research to find out to read the hieroglyphics. But nowadays we understand what it means, and therefore we can say it is a language and it's a real information. Nowadays the hieroglyphics are understood. On this picture you see a translation made by computer. The input of the computer was a German text, and the output of the computer via plotter was a translation into hieroglyphs. It is because we understand this language and therefore translations are possible. A definition in science must be precise and very clear. It must have sharp, distinct borders that include only the subjects of the definition and exclude everything else. We need such a definition also for information. If we use such a term in science, we have to make a very clear definition. Let me say it an example of energy. Energy is in many cases in our normal speech used. If a sportler is very good in sport, so we say he has very good energy. Or if somebody is writing many letters or books or whatever, we say he has energy to do it. But that is okay if we do it in normal speech. But if we use the term energy in physics for a law of nature, we have to make a very, very clear definition. And the definition of energy in physics is force multiplied by distance. Now it's clear what energy is. And now it's possible to formulate a law of nature. And the same is what we have to do for information. Information is a term we use in many, many cases in our normal speech. And if we want to formulate laws of nature about information, we need a very clear definition of information. Let me give an overview about the contents. First, we will speak about fundamentals in science, systems based on information. Then we will have a look to find 7 strong conclusions. Part 1, Fundamentals in Science. How to refute false ideas in science. Let me start with an example in mathematics. That is very important in science, that we find what is the wrong situation and what is the right situation. Let me give another example in physics. Water is running up and falls down in a waterfall. As you see in mathematics, you see there is an equation, and you see the equation is false because a law of mathematics is violated. And you see the other equation which is right. 2 statements about laws of nature and searching for information in biological systems before we will find the laws of nature about information. And the most important thing of this lecture is